Hello everyone, welcome to another math video for 4th grade. So today we're going to be covering the topic of factors, multiples, and finding prime and composite factors. Now, in 3rd grade we learned that factors are the two numbers, or more numbers, that make up a product. So for example, in this equation, our product is 6. And the two factors that make 6 are 2 and 3. Now, when we want to find factors of a certain number, it's basically asking what are all the different ways that we can multiply different factors to get a product. So let's use this example. This is the number 6. So if we want to find the factors of 6, what we're going to do here is we can always, a rule that we know for factors is that every number can use a factor of 1. And of course, it pairs up with the number itself. So in this example, 6, right? What multiplies 1 by 6, we're trying to figure out, right? 1 times something is going to equal 6. And we know with our property of 1 that in multiplication, anytime we multiply a number by itself and 1, it's going to be the same number, 6. So we already know one factor pair of 6 is 1 and itself, 6. So a factor pair, what I mentioned here, is two numbers that work together to make your product. So we know that to find factors of 6, it can be 1 and 6, or we can say 6 and 1. Now, to find more factors, right, there are some factor rules. One factor rule is that all even numbers have a factor of 2. So, right away, what I'm going to do with my factor pair is I'm going to turn it into what I call a factor rainbow. I think this helps me because I want to see all the factor pairs in order from least to greatest. So I'm going to take 2, and one tool that I like to use is my multiplication chart. So if I look for a 2 as a factor, there's 2, and I gotta see how many 2's it makes to get 6. Of course, 2 times 0 is 0. So if I go 1, 2 times 2, 2 times 3, it looks like our pair that will work together with 2 is 3. So, if I look at my chart, I also know the factor rule of if it is a multiple of 3, so that means, for example, if you can skip count by 3, 6, 9, of course 9 is, our 2 3's make up a 6, so 3 will also be a factor. Now I'm going to test, can like a 4 make a 6? I'm going to use multiples of 4, which is basically skip counting. So if I go like 4, 8, oh wait, I see that 8's already more than 6. So it's looking like, guys, maybe I try 5, 5, 10, 15. Oh, I noticed with multiples of 5, everything's going to end either in a 5 or a 0. Of course, 6 does not end in a 5 or a 0, so that's a rule that we got to make sure that numbers will have a factor of 5 if they end in 5 or 0. So, of course, 6 does not end in 5 or 0, so that does not mean it will have 5 as a factor as well. Of course, 9 is already way larger than 6. 7 is larger than 6, 8, and of course 10. So it's looking like I have found all the factors of 6. So my factors of 6 are going to be 1, 2, 3, and 6, right? Making 2 total pairs because I see in my rainbow there's 1 pair, there's 2. Now, you might be asked about when you find factors of a number, if a number is prime or composite. For a number to be prime, it can only have factors of 1 and itself. So if I look at my factor list, I notice that, yes, there is 1 in itself. However, there's another factor pair, 2 and 3. So this is not prime. This would be a composite number. So 6 is composite because it has more than just the factor pair of 1 in itself. Now, some people might ask, well, what's an example of a prime? number. So usually, right, you won't have a number that can be end in a 5 or a 10 because it is going to have a factor of 5 in it. Or if you have a number that ends in 0, it's a 10, right? So it's going to have a factor of 10. So in this case, 70 has factors of 7 and 10, so it can't work that way. What can be a prime number? Well, for example, we have things like 11. 11 only has a factor pair of 1 in itself. We have numbers like 29, because that has 1 in itself. And even numbers like 67 have a factor pair of just 1 and itself. Now, a fun rule to remember is, of course, every number has the factor pair of 1 in itself. But the number 1 is neither prime or composite. So, a little fun fact. Why is it not prime or composite? I'll just put comp for composite. It's because to be prime, it has to have a factor pair of 1 in itself. Now, you might be thinking, isn't 1 and 1 just a pair, kind of like two shoes? No, it's not a pair. It's just one number that multiplies by itself. So usually when I make a factor rainbow, so for example, like a number 9, I know that it has factors of 1, 9, and 3. But it's 3 times 3 to make 9, so I just do a little rainbow to connect 3 to itself. So the factors of 9 are 1, 3, and 9. Now, those are kind of what factors are. So factors are basically every number that you can use to multiply, right? And I want to go to my camera, and this is probably not going to be the best camera work here, so please bear with me. You can see my studio here. It's just a computer. But I'm just going to show some factor rules here that can be helpful as well. So, factor rules. So 2 is a factor of all even numbers. So 2, 4, 6, 8, 10, 22, 24, 26. So if it ends in 2, 4, 6, 8, or is a 10, like 10, 20, 30, 40, it will have 2 as a factor. 3 is a factor if sum of the digits is divisible by 3. So for example, 3, 6, 9, if your number will typically ends, there are some that don't, but if you take the numbers and the digits of the number and add them up, say for like 12, the 1 plus the 2 equals 3, so we'll have a factor of 3. 5, of course, is a factor if it ends in a 0 or 5, so 10, 15, 20, 25, 30 will all have factors of 5. 6 is a factor if it is divisible by 2 and 3, so if you notice that you have 2 and 3 as a factor, most likely you're going to have 6. 9 is a factor too if the sum of the digits is divisible by 9, so of course, if you take 81, you do 8 plus 1, it equals a 9. And lastly, 10 is a factor if it ends with a 0, so like 10, 20, 30, and 1 is always a factor. Now, so those are some factor rules to remember. And we're going to lastly talk about multiples. So I'm going to erase, sorry, my messy, so excuse me, sometimes I kind of go quick here with the video format. So here we have factors of 6, and a key thing to remember is that when we have factors of a number, right, is that all factors, right, are smaller than the number, or can be the number itself. And the reason is, right, factors make up the numbers we multiply in order to get a product, in this example, 6, right? So 1 times 6 equals 6. We look, 6 and 1 are factors because 6 is itself, 1 is less than 6. 2 and 3 are factors, are less than 6 because you need the two lower numbers to multiply to get the product of 6. Now I want to talk about multiples here. So if we want to do multiples of 6, it's pretty simple. It's basically your multiplication facts, right? So multiples of 6 are basically anything that you can use 6 and then you multiply it by another number to get kind of skip counts of 6. So the first 5 multiples of 6 would be, for example, the first one is 6 itself because 6 times 1 equals 6. The next multiple of 6 is going to be what 6 times 2 is, 12. 6 times 3 equals 18. 6 times 4 equals 24. So the first 4 multiples of 6 would be 6, 12, 18, and 24. 6 times 5, the fifth multiple would be 30. 6 times 6 equals 36, and so on. And so an easier way to kind of do it is using your multiplication chart. It's basically going in order, so if you want to find different multiples of 6, you can look right here. So right here we have 6. It goes 6 times 1 is 6, 6 times 2, 12, 18, 24, 30, 36. So multiples of a number are going to be itself and greater numbers that you can skip count or multiply with 6 to get a product, right, that is divisible by 6, because we know 12 divided by 6 is going to be 2. 18 divided by 6 is going to be 3, right? So they have kind of a 6 inside them, or multiple 6s inside each number, so 6, 12, 18, 24, 30. So one thing that can be confusing is sometimes people might say, oh yeah, 12 is a factor of 6. And that is not true. It's the opposite way around, because what we're saying is if we're saying 12 is a factor, we're saying 12 times a number equals 6, and we already know 12 is a lot more than 6. So 12 is not a factor, it's a multiple of 6. But 12 does have a factor of 6 because if we look at 12, one of its factors is 6 because you can use 6 times 2 equals 12. So please make sure you're not getting confused. Multiples, it's like skip counting by your multiplication facts of that number. So for example, 6, we have 6, 12, 18, 24, 30, 36. So it kind of starts with numbers that are itself because 6 times 1 equals 6. And then things you can skip count with groups of 6 or multiples of 6. That's why we call it multiples. So it can go all the way even farther. So you can do like 6 times 7 is 42. So 42 is a multiple of 6, right? But if you're trying to find factors of 6, it's basically the numbers that you can multiply to equal a product of 6. It should not be, right, a number that goes over 6, or else it's going to be a multiple. So please be wary. Well, so that was kind of a quick review on factors and multiples. I hope that is very helpful for, I know, this week's Wednesday homework and beyond, because we're going to need to know our multiples of numbers. Helps with divisibility as well as factors, because we're going to be covering a lot of multi-step word problems with multiplication, division, and later on some multi-digit multiplication and division. So knowing your multiples, right, your skip counting of numbers such as 6, like going 6, 12, 18, 24, 30, 36 is going to help with that. And also just knowing the factors, because of course with fact families, like for example, if you know 2 times 3 equals 6, if we can flip it, we would know that 3 times 2 also equals 6, or we take our product, turned it into a dividend, and one of the factors into a divisor. 6 divided by 3 equals 2, 6 divided by 2 equals 3. So, your homework's going to ask you about prime and composite this week, so remember, prime can only have factors of 1 and itself. For examples, like the number 11, right? Can only have 1 times 11. You cannot do 2s, you cannot do 3s, 4s as factors, 5s, and so on, right? So, composite, just like our number 6 here, has more than just the factor pair of 1 in itself. It also has 2 and 3 as factors as well. So, hope this video can be helpful once again, and stay tuned for more.